Hey, what's up guys? On today's video, we are going to talk about Goroutine and channels. And this is for part 1, but for part 2, that's what we're going to make on next video. So for Goroutine, we're going to explain what's Goroutine and going to give you 2 examples. And for channels, we're going to to explain what is unbuffered channel pipeline and a unidirectional channel type and a buffer channels. So before we dive in for the Goroutine, so what exactly is Goroutine? So Goroutine is if we look at this image, so we have if you're using another programming language like Java, you might have the concept called thread, but Goroutine is a different concept. It's like a thread, but it's much more lightweight. As you can see, if we fire a thread, it's gonna be gonna cost you like 1 megabyte, and for Goroutine, if you fire a Goroutine, it's only gonna cost you like 2 KB, and it's managed by Go runtime, and the thread is managed by operation system. And let me show you another image here. As you can see, if we use a thread, so let me do it like this. If we use the thread, it's like this. We fire a thread, it's gonna run it at same time, exactly on same time. And if we're gonna do like a Goroutine, is concurrency. So if we fire one Goroutine, it's like this. It's like this is the one Goroutine, that's another one. This is 5 different Goroutine, but they are not like executing at same time. They do that like concurrently. So if we finish that one, and you're gonna do this one, and if you done this, you're gonna come with that one, and you can, cause this is super lightweight, right? So you can fire like so many Goroutines in the program, and it gonna help you. It gonna make you project more efficient. And all of this are managed by Go runtime. The Goroutine is managed by Go runtime. So that's why it's like very popular on web, like cloud on web server. Okay, so let's dive in for you. Let me give you some examples. How can we use for the Goroutine? So to have a Goroutine, if we have a function here, so we just simply add Go on we add Go before the function. So this is on line 19 is normal function, and the line 18, that's the Goroutine. So okay, so this the Goroutine. So basically, if we run the program here, right? That actually fire 2 Goroutines. So this is the main function. That's the main Goroutine. That is the new Goroutine. So if we run the project, right? So so like this, we run the project. That Goroutine is a Go. If fire a Goroutine is like this. It's like this. They fire a task, but we can't really manage that. It's like on another box. So if you think this main is a box, and if you have a Goroutine, that's on another box. So if we run the program here, it run the Goroutine that's on another box. We don't need to care about that for now. And we have a function here. We call say, and they say every 100 milliseconds, it's gonna print out the to print out this hello, and for here, it's also gonna print out. It's not gonna print out word. So let's see. So if you can see here, we have it print out like hello word, hello word. So it's like it's so random. It's not in the order. So because that the Go routine is managed by Go runtime. So it's going to print. It's gonna print out whenever it's ready. So they are going to like on every. So this hello gonna print out on every 100 millisecond, and the word gonna print out on every 100 millisecond. And let me show you something like interesting. So if we swap it, and we say like hello, and we call the function, and we fire a Go routine. So let's see the result here. Can you see it doesn't print out word anymore here? It only print out hello because we run this function, and this function is on the main Go routine, and this is on the new Go routine. So if we just ignore that for now, so we run this. We say we done this function, and we're gonna fire a Go routine, and this main Go routine finished, and that's still another like new Go routine. He haven't got a chance to run, and we finished the program. So we need to make sure if you have a Go routine, you need to make sure the before program finish, or before that program finish, we need to make sure the Go routine is finished running. Okay, so that is kind of tricky. So you're gonna get used to that. And so let me just give you an example on concurrent clock server. So we have a we have a server here. We create a server, and we listen for the connection, and for it, as you can see here, handle each connection in the new Go routine. So if there's 2 users or more users can visit this server, that we're gonna, if we have 2 people, let's say 2 people visit this server, it's gonna fire like 2 Go routine, and they don't actually interfere with each other. They are all independent. So for this example, let's say, let me see, you can see. So so we're gonna run. No, sorry. Gonna start the program. So we're gonna visit the server, and it print out the time, and that's another second user gonna visit the server. It also gonna print out the time. They don't actually, they are like independent. They don't interfere with each other, and so this is the good thing about a Go routine. So it's like if you have like more processing to do. They all all users, they are all independent to each other. And it's the super lightweight. You can have thousands and thousands users to visit a very like a very small server. And of course that we don't fire a thread or anything. We just like we fire a Go routine, and it's lightweight. Okay, let's move on to let's move on for the next one. That's the echo server. Let me show you an example. So we have an echo server here. So same as previous one, we have the each user, like for each user we fire a Go routine, and on here, and whatever user like user input, whatever user input in here, right? And we're gonna print it out. So we print out with three logs. The first one with the whatever user input is, we're gonna make it uppercase, like full uppercase for all letters, and we print out user's input, and we're gonna print out like on lowercase. Okay, so let me just start server. So let's try that. Actually, before we try that, I just let you know we fire this handle connection. That's we fire a Go routine, and for each echo we fire a new Go routine. So we just make sure they are all separated. So let's say hello with the capital letter H, and it's gonna bring out with four capital letter and the user's input and the lowercase. And for this, let's say word, hello word, and I would do hello here as well. So we're gonna run them like at the same time. Let me just say, look at they all separate. They all separated, so they don't actually interfere with, because they are on different Go routine. So basically the concept is like Go routine is like a box. It's like another thread, another lightweight thread, and what we are having like for each user, we're gonna put them in different thread, and on all different thread, they don't interfere with each other. They are all independent. So in order for the Go routine to communicate, we have something called channel. So that's the we use channel to communicate between Go routines. So let's start. We have different type of channels. So start with unbuffered channel. Unbuffered channel, like channel, we have receiver and sender and receiver. And for unbuffered channel, it means it's gonna block until the receiver and server gonna block until like receiver receives the data. And by creating a channel, we use the a method called mate and a CHAN channel, and we're gonna define the type that's gonna be integer. And for next, we're gonna talk about this like a buffer channel later, that actually take the second param for buffer channel. So for channel here, so this is the one Go routine. Yeah, and this main is another, that's main Go routine. So they need to communicate. So let's say new Goroutine. So if we don't have channel here, we might not able to print out this. Let's comment that. We might not able to print out this new Goroutine. Let's try that. Okay, you see that there's not locking here, because the main finished before this new Goroutine actually executed. So in order to make sure this executed, we can use a channel. So we run this program, and that fire the new Goroutine, and that print out, and it's gonna send some data to the channel, and the main Goroutine gonna wait. It's going to wait until it receives the data from channel. So let me try that. It's gonna bring out new Goroutine and bring out this data 42. Can you see that? We bring out the new Goroutine and the number and the data from the channel. Because like this is unbuffered channel, because they gonna block the process, and it's like it communicate between Goroutines. Okay, so next move on for pipeline. So pipeline is another unbuffered channel, but it has like more Goroutines, so it make it a series. So let me just easier to show you with the code. Okay, if we look at this code, we have two different channels called naturals and the square. Okay, so this is self-involved function. So this is the full range that listen to the square channel if anything's coming. So we're gonna run this program, and it's gonna be hold here until it got everything in the channel, until this channel is closed. So if we run the program, so it's gonna start it from here. So it's gonna loop 10 times. For each time, it's gonna pass a value to the channel called naturals, and they're gonna hold it there because we need to wait for the natural channel to receive data. So if fire up this, gonna fire out this. These two actually they're gonna fire out. You can think of they fire out at the same time. So this is gonna be standby until some data is flowing into the channel. So it got data passing to the channel, and this it receives the channel. It receives the data from channel, and I take out the data, and it multiply by himself, and I put it back into the square channel, and it's gonna loop that for 10 times, and for every time it passing the data to squares, and we are able to print out the data. So it will be like a 0. Let me see, I can't really calculate now. Let's do it with the program here. As you can see, for like 0, that's 0, and for 1, that's 1, and for 2, because it multiply by himself, and so that's gonna be 4, and 3, that's gonna be 9. So this is like we have a data that passing to neutrals, and a neutral is passing to square channel, and the square channel and a square channel, it do some like processing, and it pass out. It gonna output some like calculated data, and we are able to get the data out from square here. Okay, so this is the like kind of like pipeline. You can do this is like a very simple pipeline, and in reality, in a real project, you might have like a bit more complex channel. On here we only have 2 channel. So channel is just make sure everything is doing like step by step, so we don't skip any steps. So you need to always follow 1, 2, 3, 4, like in step procedures. Okay, so let's move on to next. Unidirectional channels. So from previous example, we just do some optimal. So on here we just wrap it as a function here. So in function, we need to define the channel type. So in so let me have a look. We have the counter, we have a print, we have a printer, let's say range. So this is like a let me see, this is the square passing a square. Yeah, here. So we have a counter square and the printers, and the counter here. So as you can see, that's a channel. We passing a channel as a param. So we need to define the channel type. So that's the arrow to the channel. It means that we have a data to pass into the channel, and then like this, the arrow is on the left hand side of channel here. So it means the data is output from channel. So by doing that, like we can wrap, instead of previous example, we have self-involved function, but here we have the more organized function, like we have a counter that's the independent function, and by doing that, that's the only one way. We have defined the pipeline, the channel is the only one way, and for this, like that's something output from this channel, and we can't really put the data in there. So it's just better to organize the code, and better, it's more clear. Okay, let's move on for next. So the final one I want to talk about is called buffered channel. So the buffer channel, like as we say, the channel has a sender and the receiver, and for buffer channel, when you sending to the data sending to the buffer channel, you don't need to wait for the receiver, because that you have buffer here, like because that if you have a 2, so you can pass 2 data in there without waiting receiver to receive. So for this example, we can pass like 2 datas. We don't need to wait for the first one to receive, then pass second one. We can put in like 2 datas at the same time, so we are able to receive that. You don't actually, it's not gonna block or anything. So let's run this. As you can see, we can get the data out. Okay, we're gonna talk about like more about buffer channel on part 2, and it's a bit more complex, and there's like a synchronous function and between two goroutines. Okay, that's it for this video. I'll see you guys on next video then. Bye for now.